Project Eagle. The challenge is to design and build the largest and most technologically and environmentally advanced cruise ship in history. I'm Roland Smith. This is the story of creating what has never been done before. It is taking an idea to implementation. It is a cruise ship so immense, there is none other like it in the world. In this, the first of our three-part series, you'll see why and how what started out as just another modern cruise ship grew in concept and in reality to be far larger than any cruise ship ever built. In the 2 years it will take to build the first Eagle-class ship, the Voyager of the seas, designers and engineers will face serious challenges turning the tiny idea into the immensity of a ship. The shipyard will have to construct a cruise ship substantially larger and more complex than any other in history. And at the offices of the owner, Royal Caribbean International, everyone involved will be pushed to their limit as they oversee building not only the first 3 Eagle-class ships, but simultaneously embark on design and construction of 5 more large ships in other shipyards. Construction can be a dangerous time, especially aboard a ship. We'll see how workers deal with day-to-day problems, and we'll go behind the scenes to see how the complexity and enormity of the project will stretch the resources of the yard and the cruise line in a race to build and outfit the ship in just 2 years. A destructive onboard fire during construction will set the project a month behind schedule. The project will grow well beyond initial ideas, expanding in size, complexity, and cost. Our cameras will take you on a momentous journey into the many stories behind the scenes, and it begins 2 years earlier in the minds of men and women with vision.
We knew for quite some time that what we wanted to do was offer a different type of product that offered more variety, more choice, more selection.
There are very few industries that have such potential growth as the cruise industry does. Our competition is Vegas. Our competition is Hawaii. It's definitely Disney, Orlando. And that's what we're looking to do, is to give the people today who go to the resorts of the world an opportunity to spend their resort time at sea.
When you design a ship, it's not like building a house where you say, I want 6,000 square feet or 7,000 square feet, and you know what that means. When we started, we knew we were going to be building a ship that was bigger than the, in effect, then standard, which was sort of in the 75,000 ton range. I think I would have guessed at the beginning it would have been in the 110,000 ton range. But when you started adding all the new things that we added, and in particular Studio B took up a great deal of space, we wanted the dining room experience to be spectacular, and when we added all those things together, we ended up with a bigger ship than we originally intended.
Cruise ships over the past 20 years have gotten bigger and bigger. There are several reasons why.
Like no vacation on Earth. We don't say like no cruise on Earth. It's like no vacation on Earth. We're positioning our vacation experience as a viable vacation option, not as a cruise experience, but a viable vacation, relevant vacation option to anything you can do on land. You can do on our ships and really experience the vacation of a lifetime.
And we have to give them these options, and all of our research has shown us that, and the Eagle will display the result of a lot of that.
In a quest to add many new activities and accommodate a larger passenger load, the ships keep growing and growing.
Is bigger better? And why? You know, one, is it? Is it better? And if so, why?
Actually, from a cost side, the bigger it is, the more cost effective it is. It's where you get into the smaller vessels that you lose that efficiency.
What we're building is going to be so much more spectacular than our competition. All our competition did was go out and take one of their existing ships and made it bigger. We're basically going at it from a whole new concept and design, and basically we've taken a greenfield approach and we're making it different.
Say to someone, this is the largest passenger cruise ship ever built, and that statement inevitably invites comments and comparisons to the Titanic. The fact is, the Titanic was the largest of its era, All other comparisons really don't fit. Ship sizes are measured in gross tonnage, and that in turn is based on the volume of the ship. The Titanic, for instance, was 46,329 gross tons. Huge for her day. But the technology and materials to build bigger and more sound vessels would advance rapidly. The QE2, 70,327 tons. The Queen Mary, 81,237 gross tons. The U.S. Navy's biggest aircraft carriers, the Nimitz class, are an enormous 100,000 gross tons each. The largest ship afloat as of the year 2000 is actually a supertanker, the Jare Viking, that comes in at an incredible 260,851 gross tons. Before Voyager of the Seas, Princess Cruises' Grand Princess was the largest cruise ship at 114,000 tons. The Voyager of the Seas at 137,300 gross tons, 214 feet high and 1,020 feet long, is by far the largest cruise ship ever built. In fact, if you stood an Eagle ship on end, it would be nearly the same height as the Empire State Building. The initial reaction to the idea of a ship this size by some people is not positive. Many express concern over being part of a large crowd on their vacation.
Well, we took size and used it to the advantage of what we think is going to be a phenomenal customer experience. This is a ship where you don't want to apologize for the size, because unless you built it this big, you can never give the experience that we're going to deliver today.
Developing the initial ideas into a workable plan and actually building the ship will be a daunting task. But long before any serious work on the new ship could be considered, the financing had to be arranged.
When we were building the Sovereign of the Seas, the financing of it was a critical path from day one. Arranging for the financing with the lenders and everything else. And that actually was a big distraction from the process of designing the ship, because it took a lot of time and a lot of focus. And so you spent as much time figuring out how you were going to finance it as you did how you were going to build it. For the Eagle, we had now expanded. We had moved into our mega brand strategy. We had developed the company, and we had gone through a series of financial maneuvers so that we had in place the financing that we needed. We had gone public, we had provided equity, we had provided debt financing, we had the capital markets available to us. And so our liquidity when we entered into the contract for the Eagle project was not $15 million, but $1 billion. I will admit that if you are the person that has to sign a contract for $1 billion and $4 million, that is a scary event in any person's lifetime.
Detailed planning is started 3 years before construction. Mr. Fain turned to a highly experienced manager for the project, Harri Kalavara, a naval architect and a native of Finland. Kalavara has supervised passenger shipbuilding at all the major European yards.
Naval architecture, shipbuilding is art, it's not science. And that's why it's so fascinating to my mind. This is about project number 39, which I have been the responsible, let's say, project manager from the plain paper onto the finish.
Kalavara and his staff retain noted Norwegian ship designer and architect Njål Ide. Ide's job is a big one: develop the initial concept into a ship design that works functionally and aesthetically.
I've been working since 1981, starting with Song of America, and all their ships after that, I would say probably rather central in the planning position together with the owners. I'm being called the circle man, and I've been called the atrium man, but it's got to do with shapes and volume. And I've been lucky to be able to work with volume, because without the volume you can actually not create anything. But it's you have to be very responsible to in some way form the volume. And that's why the target is, the balance between everything. So hopefully one have succeeded a bit. And even Richard Fain sent me a ruler once and said, couldn't you please do a bit more of this? But then he sent to some of the other architects a compass and said, couldn't you do more of this? Karl Levander is a very skilled and experienced naval architect. I have known him probably for about 20 years. He's actually I think the first one in the market that really started analyzing what cruise was back, I'll call it after the 1970s or something, but he was fantastic.
We do the layout of the vessel. We need to check the strength of the vessel, so but not in a way so that you have it dimensioned, but so that we know that it's feasible to build it. And the most important
Although Kai Levander is with the Kværner-Møse Yard's design group, he is retained as a consultant even before any decision is made as to which yard will build the ships. Kværner-Møse, which has large shipyards in Helsinki and Turku, eventually wins the contract. They are one of only 2 shipyards with the cruise ship experience and dry docks large enough to build the Eagle-class ships. Designing any ship is a complex task, but when it grows to this size, even the engineers and managers have to stop and take a deep breath.
What I felt was the biggest challenge was the volume of the ship. Not the volume as such, but the thing that if you deal with a ship which is half size, you have only the half amount of everything. And when the volume is growing and the number of things is growing, it tends to grow in a way which is not double, it may be 4 times or 8 times.
Now all of a sudden, a ship that size twice as large with many more options, we were trying to apply the same principles for the Eagle ship to start off with, which didn't work. And so we had to have a paradigm change and then start from scratch and say, well, let's forget everything we know.
It doesn't follow a sort of a slope. It's just another one, it's a little bigger. This is a step, quite a big step.
One of the major challenges is the control of the ships. The ports and the fairways are exactly the same dimensions as they are for the existing ships, and when the ship size is increasing, so clearly the margins are decreasing.
Royal Caribbean's chairman Richard Fain was no stranger to building ships. His very direct involvement will be seen throughout the design phase and right through the building process.
Richard's the real visionary behind these ships. He sees things that other people don't see, and he has a real incredible feel for design and dimension. And I mean, we'll be focused on a room in this design process, and we'll be looking at a floor layout, and I'll be looking to see, you know, is there enough space here to pass between the bar and this table over here? And Richard's looking at the same thing, but he's also connecting with an air conditioning duct 4 levels up that's over in this corner, okay, that if he could just get this piece of refrigeration moved over here, we could pick up a whole new table, and then you could move the air conditioning duct down 1 level and reroute it back this way, and he just picked up 200 square feet. Only Richard sees that. And I sit there and go, my God, you know, he's not even seeing the same ship that I'm seeing.
Richard is also a person who knows exactly what he wants, and of course in the process, as he is as involved as he is in the process, so of course a number of things which in the design of the vessels which you can directly say that this is as it is because he has wanted it to be in that way.
What we started out saying is we want these kinds of facilities. And actually, a big question is just how do you handle the logistics on board? You want to make it easy for the passenger to get around and find his or her way around the ship. You want to make it easy for their luggage to get to where it's supposed to be quickly and efficiently. You have to make sure that you have efficient ways for the garbage to go the other direction so that you can handle it easily, and if you handle it easily, it'll be done better. That the amount of creativity grows commensurately.
By the time it's all done, there will be 28 architectural firms and over 3,800 designers and architects working on various parts of the ship.
pretty much what y'all was showing.
A steering committee is given the task of resolving the many conflicts of opinion and direction, which are the natural result of so many creative talents working on one project.
It's not the most efficient way to do things, but I think it is one of the most innovative and one of the most creativity-generating ways I can think of, because we get everybody together. We get competing architects together in a room, watch each other present, and actually make constructive suggestions. Other questions or comments?
The major public areas of the ship are now defined, and a general layout is made. Every area is assigned a sponsor from Royal Caribbean.
I'm the project sponsor for my areas, which is the casino. We actually have 2 casinos on Project Eagle. The gift shops, the photo gallery, the beauty salon, beauty spa operation, also the gym, which is going to be the largest afloat.
This is going to be a magnificent dining room. Even it's one dining room, it has this huge opening in the middle, these balconies where you can look down and see what's going on underneath, and it'll be very spectacular.
If you drive around Europe, you see everywhere signs that say, this way to the center of town. If you knew where you were relative to the center of town, you knew where everything was. We wanted to take that concept one step further with the Eagle design. And that's really where we had the idea of almost a central city core that was bigger, broader, and that's really how the design built up.
We also have another performance space that we're calling Studio B now, that is like a television studio, but it's also an arena, it's also an ice rink. It's a very highly interactive, fun space. It's a brand new space for us, and for the industry, one of the first of its kind.
We wanted a very extravagant outdoor sports activity with a full basketball court and rock climbing and golf and volleyball and rollerblading and golf simulators and all the things that you could want to have. And one of the component parts of that was going to be an enclosed and air-conditioned basketball court. And we decided that we would prefer that to be open. And that was one of those issues in which there was fairly strong feelings on both sides.
People sometimes lose track of where they are, particularly as big as a ship is. They forget that this really is a ship. Well, why don't you have a bowling alley? You know, why don't you have pool tables? You know, well, basically, we do have a miniature golf course, and the ball does go like this if the ship rolls. But you know, in golf, you can say the rub of the green, but usually in bowling, you don't expect the ball to go in the gutter. At least go in the gutter on its own. And usually, it's driven there by you. So it is kind of funny the things that people do ask to have on a ship.
Throughout 1996 and 97, as designers and architects plan the details of each space, structural engineers and marine architects are busy finalizing the main ship structures and steel fabrication plans. At one point, it is decided to raise the height of Deck 6 by 1 foot, a significant change. We talked about it with the yard's design engineer.
They wanted to have more headroom for the public rooms. We had to make some calculations for the weight also and the stability, for the stability of the ship.
If you raise it 1 foot, can that really affect the stability that much?
Yes, big effect on the stability.
Areas like the stern design are so complicated that specialists are brought in to engineer the critical structures.
The basic design is done. We're putting in specific parts and stiffeners and plate sizes and working out any problems that may have occurred during the preliminary design. There's still a lot of design work that needs to be ironed out.
An ongoing problem for the yard will be standardizing all the work done by many different design and engineering groups, many from different countries. And of course, like any big construction project, there will be changes.
The ship is constantly changing, so we're constantly having to continually change the design. It's like a domino effect. So if a deck changes, that changes all your measurements. to the next deck and so on.
The CAD drawings from Robert, Dwayne, and many other engineers are finalized, checked, then downloaded digitally to a person called a nester.
A nester is, they nest the parts. Actually what that is you take a plate and you put all these different parts that we've created in modeling, and you put them on a plate, a particular thickness of a plate, and a machine out in the yard burns those parts that we've created. And so exactly what we do here in the computer, a machine cuts it out there. We do it wrong, it gets made wrong. We do it right, it gets made right.
From ideas to sketches, then artist renderings, it's still hard to imagine just exactly what an area is going to look like full size. How will it look and feel? As a way to test the size and scale, models are built for all the major public spaces.
This is the jazz club at night with the stage here. And then the other areas in here, there's a cocktail lounge here and a card room. And there's a dividing wall here which can be taken away, and this whole thing can be a cocktail lounge. And the reason that's good is because upstairs in the funnel here is the chapel for the ship. And there will be weddings in this chapel on the day of embarkation. And so people will get married here, come down the stairs and hold their reception. This is the two-story central space of the nightclub. This is a way of studying how we're developing this space, because being a nightclub, it depends very much on lighting. And we were asked to do a high-tech theme for this space. And I think this space actually has complete state-of-the-art lighting and sound. Everybody on this project has been very concerned about the acoustics. And a nightclub functions till 4 in the morning. So
the sound insulation is a very big part of designing.
So
we have floating floors, we have
and the whole
thing
is
encapsulated.
Yeah.
And that's also why we came, the concept is that the actual dance floor, where most of the noise is in the central part. So we tried to keep that internal, and then you have the quieter areas around towards all the other areas on the ship.
Actually, it turns out the most difficult thing concerning the noise is to stop sound being transferred through the air conditioning system, because you pad the whole room and then find that noise is seeping out through the ductwork. So that has been a problem. From our point of view, it was not so difficult, but for the yard, I think it has been extremely difficult to divert the air conditioning system so that we have a separate system which is only working for the nightclub and not transmitting sound.
We've really made a big attempt to try to physically hide the technology. One aspect of doing that, as you see, is the video cube, which is behind the screen. In the true space on Eagle, you will have 21 of these video cubes within the space.
The Royal Promenade design is based on an actual street in Milan, Italy. Designing an open space this large on a ship presents some serious challenges structurally.
One of the big issues early on was the width of the Royal Promenade. Structurally, the yard said we would like to keep that at 8 meters. And we decided that it would be significantly better to the ambiance to make it 9 meters. And we made models and we made simulations, and we really wanted to get that extra meter out of it. We also wanted more glass in the cabin walls. And the initial response from the yard and from the outside engineers was you couldn't do that. And I went to Harry Coulavara on that, and I said, Harry, I think 8 meters worries me a little bit. 8 meters is acceptable, but we're not trying to get an acceptable. We want, and that extra meter, and there were various reasons why that meter helped quite a bit in terms of the ambiance. That extra meter is quite important. And he said, well, let's see, if we do this and we do that, then terrace this in, and we add an additional support member here, then I think we can get the 9 meters. And the yard came back and said, well, okay, I think we can do it at 8.5 meters. And Harry and I said, well, you know, but it really ought to be 9 meters, and if you can do 8.5, you've already got off the concept that it has to be exactly in a plane, and you can go to 9. And they came back and they said, well, it can be 8.9 meters. And, you know, it's really 9 meters, but we're not going to count this. And I said, well, no, you know, 9 meters ought to mean 9 meters. And they went back, and sure enough, they made it 9 meters. There were a number of things like that, actually, that Harry really was able to focus on and pound on the table on and really get what was needed.
When we introduced and wanted to go for the horizontal atrium, wanted to be sure that this, from the fire safety point of view, is something which gives an advantage. We all know that is one of the let's say the worst accidents what can happen on a ship. With the atrium solution, we have created a shape which is, let's say, safer in case a fire will burst.
The promenade spans 3 fire zones, which means giant fire doors must be built to isolate each zone to contain any fire in the area. Designing fire doors for a 4-story high open space on a ship has never been done. It was relatively easy for the engineers to create it on paper, but it would take much more than a computer model to convince the Certification Society and U.S. Coast Guard that they would actually work. Mock-ups and numerous tests would be required. Even as late as sea trials, the big fire doors would remain a major inspection item, since they must work in a rolling sea and must close relatively quickly. The Eagle ships have a new engine room design. Even if there were to be an engine room fire, a worst-case scenario, safety and reliability are part of the design criteria.
On the safety side, so one of I think most crucial element what we have done here is on the machinery side, where the ship has been built with 2 totally independent machinery rooms, engine spaces. We have 6 main engines which generate the electric power what is needed for the ship's, let's say, different services and also for the propulsion. And these are divided into 2 rooms which are totally independent, which doesn't have anything in common, where they have totally independent. If something knocks out one room, so we will have 50% of the power available in order to let's say, to run the ship and provide the services.
With 6 engines and 6 generators, it is possible to run the entire ship with several engines shut down for maintenance and still have a backup. The entire engine room is really like a city power plant, since virtually the entire ship runs on electricity. Total power output is about the same as a small city.
Yeah, we have 6 diesels, which are producing 12.6 megawatt of electricity produced in generators, 1 generator for each diesel. If everything are run 100%, you produce 75.6 megawatt of electricity.
Architects translate ideas into concepts, drawings, then into models and mock-ups. Nowhere is this as important as when it comes to cabins. Nestled among the gently rolling hills of Finland, just 20 kilometers from the yard in Turku, is the Pakia Cabin Factory. The cabins are built as individual units, with electrical wiring, plumbing, cabinetry, all complete. They will be tucked into the ship, welded into place and connected to the ship's systems. All that will need to be added is flooring and furniture. All the cabins except the largest suites will be built at this factory. The suites are custom built aboard the ship. It is April 14th, 1998, and the factory has built many scale models and test rooms for hallways and cabins. Hundreds of combinations of colors, textures, mirrors, fixtures, and furniture will be designed, built, and tested full size before any production line is started.
Pastel colors, really, because these cabins are small and they want to get them as airy and open as possible, and that the effect of being in the cabins is pleasant, very comfortable.
Actually, the purpose of the mock-up is to get decisions made in time, that we can start the process. Have to face the fact that decisions have to be made earlier. Of course, sometimes it would be nice to delay it and like this, but actually it doesn't help too much. Sooner or later the problems, they come. Why don't face them in the beginning?
Facing the problems of design and getting approvals in time to build some 2,000 cabins for passengers and crew is a task that takes architects and executives back to this mock-up many, many times.
Totally, we have about 2,200 cabins, and if we make, for example, 10 kilos mistake per cabin, you can easily calculate how much it means. Each kilo is 2.2 tons, so that's why it's very important. So it's a very good control for the weight, for example, which is essential for the yard.
There are so many more pieces of this puzzle needed to support this city afloat. There has to be a hospital, a jail, which in this case will be made of 2 cells, both padded. The laundry room facility will need to clean 5,000 crew uniforms, about 12,000 sheets and towels every day, and that doesn't include any passenger laundry or dry cleaning. Of course, there has to be some very large storage areas for everything from food to cleaning supplies, spare parts for all the air conditioning and other mechanical systems, hundreds of gallons of paint, even huge rolls of carpet will be stored. There are spaces for repair facilities, including full wood and metal shops.
And in order to make you understand...
Typical of the thousands of problems involving space allocation is where to put the cherry picker maintenance vehicle, which is needed in the 4-story tall Royal Promenade.
So, the solution we have settled with is this one. It's only got one drawback. It's a marvelous machine, and it needed a garage. But believe me, the yard was very kind to us because they gave us this. All of a sudden they said, we have some empty space here. Is electrical equipment, do you want it for something? And I just dropped down and said, hey, this is the garage. Finally brought this.
This is the SOLAS Book of Regulations, as determined by the International Maritime Organization. SOLAS stands for Safety of Lives at Sea. In order for a passenger ship to receive an operating safety certificate, it must comply with hundreds and hundreds of regulations.
In terms of the safety aspects, of course, we work with all kinds of different authorities, from the authorities of the flag state where the flag of this vessel will be, to the United States Coast Guard, to Norwegian Veritas, and you can get a whole long list of all the authorities that are involved in approving the vessel in terms of the safety in the fire zones and the watertight zones and all that.
A classification society, well, it's a somewhat strange animal. It's an old institution. Our institution is 133 years old. We were founded in 1864. The objective is to safeguard life, property and the environment.
The inspectors from Det Norske Veritas, based in Oslo, Norway, will review and must approve every aspect of the design, construction and testing of the ship. Without their final approval, the ship cannot be insured, cannot be certified, nor put into service.
And we work quite closely with the US Coast Guard. We are authorized by them to review passenger ships abroad prior to coming to the US. And we work together with the US Coast Guard to interpret their regulations, the CFRs, and to see to that the ship also complies with what the Coast Guard expected to.
The stability of a ship is critical to safety and to comfort. To be certified, the Eagle-class ships have to be able to recover from a roll of as much as 49.5 degrees. The maximum roll for passenger comfort is set at just 5 degrees, and the ships have to be able to withstand a beating by huge waves and remain stable with structural integrity. The huge open spaces on the Eagle-class ships, and in fact on all big cruise ships, which are multiple stories high, must be strong and rigid enough to withstand the movement and stresses of a ship at sea. And yet, like a large airplane, the ship must have some give. It must bend and twist with the huge stresses it will encounter at sea. It is a serious structural engineering challenge.
What had developed was the advent of the use of supercomputers in calculating the stresses on a cruise ship. So with the ability to calculate these stresses and in effect to buttress the side of the vessel, you could now consider building these large atriums.
The structural design concerns itself with strength first, but with a cruise ship, that's only the beginning. With only 28 feet underwater and 214 feet above, it's only natural to wonder how the ship will keep from tipping over.
Everything above the sun deck is of aluminium. We wanted to maximize the free heights and have more free heights on the public decks than what is, let's say, normal. And in order to get the margin for that, so we wanted that the top construction is as light as possible, and that's why we have done it of aluminium.
Using aluminum for the topmost structures solves the problem of too much weight on top, but that will mean finding a way to bond aluminum and steel, two metals which do not weld together because of their atomic structure. One more problem to solve. Stability comes from both weight distribution and hull design. Clearly, the heaviest parts of the ship are on the bottom. The diesels and generators, the electric transformers, the fuel, water, and all the heavy equipment, all are at the lowest levels. In the forward part of the 'tween deck are the first crew cabins and the laundry. The aft areas are open to the engine and generator spaces, while the anchor chain lockers are in the extreme forward area of the ship. Deck 0 has a large number of crew cabins forward and machinery aft. Machinery storerooms and shops are located in the aft areas of this deck. Deck 1 has a large number of crew cabins as well as the main service corridor for the ship. This is where the baggage will be loaded and all main service items flow. The ice rink, a very heavy area, is on Deck 3, still low and in the center of the ship. The ice alone will weigh 8 tons, and the retracting floor will add another 5 tons. The hull of the ship this size is an amazingly complex design. First of all, it has to have structural integrity, but there is much more to it than that.
We have been able to reduce the propeller-induced vibrations and also the noise levels almost to 1/10 of what would be normal for this kind of ship.
Let's say this is the part of the ship hull here, and when we mount this bodied Azipod system, we can have the propeller here, and you can see it immediately now. That is opposite to normal. In conventional ship you have the propeller directing to the stern, but we have it here in this Azipod units. It's like a pulling drive. And one big advantage is that when the ship moves through the water, that gets the water flow very evenly. The propeller is not disturbed.
The water flows cleanly into the propeller. You get a beautiful wake field, no turbulence. The propeller will be very easy to design. It will be easy to optimize it, and you get less noise, you get less vibration. With the Azipod, you can actually turn the propeller in any position, and you can get full power also going sideways.
There are 3 propulsion pods on the Eagle ships, 2 face forward and 1 aft. The 2 on the outside are called azipods and rotate 360 degrees, steering the ship and eliminating the need for rudders. The center pod does not move, and it's called a fixopod. Although it looks like there are rudders behind the outside pods, they are actually vertical stabilizers and do not move. They were not part of the original design. The supercomputers are amazing in predicting stability, but with the safety of the ship at stake and a new hull design, extensive model tank testing will be done before any steel is cut. These exact scale models of the hull are used to test each design. One of the fascinating engineering feats is how they design the hull so the ship can move through a harbor and not put out a huge wake, which would damage boats and piers. The big bulbous bow on ships are there to start a wave of a certain form. As the wave passes down the side, a second wave is created 180 degrees out of phase with the first. When they meet, they simply cancel each other out. Without this design, the ship would put out a very destructive wake in harbors or wherever she sailed. On the Eagle-class ships, the hull is so large, this phenomenon will actually occur twice. In these early Azipod tests, flow past the propellers is checked. Notice there is nothing behind the outside pods on the hull. The fin that looks sort of like a rudder in the middle is actually a stabilizer, like the tail on an airplane, and it does not move. These models simulate exactly the weight and stability of the real ship. This is the first turning test to see how far the ship will lean in a high-speed turn. The test reveals what engineers consider a serious problem. The ship rolls far more than the designers had hoped. In a roll that steep, even though the ship won't be anywhere near capsizing, passengers and crew would probably fall down and anything not bolted down might slide around dangerously. The hull designers need to go back to work. The twin vertical stabilizers are added to the models and put to the test. In this split screen, the original and new designs are compared to look at the difference in these steep turns. The final test will come during sea trials, when hard turns at full speed are tested with the real ship. Here in the 3-story high theater, the show producers and theater architects are determined to make sure no pillars block any view. For the marine architects, it presents a formidable engineering challenge, which becomes a serious point of contention between the two groups.
It doesn't work.
After many long meetings and hundreds of structural studies, the engineers find ways to eliminate most pillars by strengthening all the main girders and adding additional cross members. But in the end, a few pillars must remain. This is just one of thousands of compromises between artists, architects, and engineers.
We're creating art for a ship, yes, where people are supposed to like what they see. I mean, it has to be very decorative. You can't take a very avant-garde painting and put on the ship because nobody would like to look at it. I mean, we have to face that a lot of the stuff that you see in modern museums, you could never, ever use on a cruise ship.
RCI was one of the new patrons of the arts because there isn't anybody spending that huge quantity of money on new, very good quality, and in some case, very highbrow artists.
Planning, commissioning artists, and coordinating the creation of what will be 56 tons of original art is a huge task. And as you can imagine, there are many discussions not only about creativity, but about the budget, which will go as high as $13 million and end up at $11 million.
Yard is saying they don't want to do it and it's going to be more money, and RCCL is saying we've already paid for it, so you are going to produce it. So there's a little argument going on.
Joan, these are the last things to go up. Why do they have to be done like 7 months in advance?
Because it takes 7 months to produce them.
But it can't do such a little job. This is them covering themselves.
This has been requested by Grabowski and approved of by John Lazell. This is done. This was done months ago. Let's get it over with.
Well, yeah, I know, but I'm just thinking you're not going to have all
I
of
know
that.
how it is. They hate sending this
such
stuff
a
in.
long time.
Because we can never foresee what is going to happen on the yard. And we can have artists sitting waiting for 3 weeks because one part of the sculpture went to Bali or whatever it went to. And then you have to try to keep that artist calm for maybe up to 3 weeks, which can be very difficult.
The ship's a living environment, a moving environment with a lot of people passing through. So they have to be safe, they have to be passenger friendly. The art pieces have to be passenger friendly. They have to be secure, they don't want to fall off. And all of these things, 99% of the artists are quite aware that their pieces are going to be touched, they're going to be abused in some cases.
If you think of a collection in a museum, certainly there's a certain amount of people that actually go to that museum to see that collection. But if you think about the thousands of passengers that come on board those ships every week that are actually seeing this beautiful collection of art, and some of them are, it's one of those situations, if they wanted to start taking off some pieces and putting it into a museum, they would have a serious art collection.
Some of the ports of the Caribbean can handle the new big ship, some cannot. Planning must include moving the passengers quickly to shore and back again, plus provisioning and care for the environment.
We know exactly what it takes to feed X number of people on this size of vessel, and we look at the menu mix at the same time. We have flow charts that we develop, which are conducive to the way that the menu is running, and it is from that that we're able to determine how much beef and ham and pork and bread, is flour and sugar and everything else that is necessary to be able to put on board a vessel.
We have to prepare for this size of ship 23,000 meals a day. I got 212 people working in the galley. We have baker, pastry, pantry, which is corn kitchen. We have vegetable, fish, roast, soup.
If you're serving, let's say, 3,000 plus guests when the ship comes out, you can't very well have frozen product that you just pull out the thaw that day. So our food operations actually plans about 3 days in advance. So they have a schedule of when different items come out of either frozen storage and goes into thawing areas, so that they can have all of the prior preparations done before the guests even come on board.
Everything I get is in Miami. Like I have 7 days consumption, 10% extra. Whatever I order is for 7 days, and I pick up only in Miami. Nothing is to be bought in any island.
Feeding and housing 4,600 people for 7 days generates a lot of garbage and waste. Before the late 80s and the early 90s, the shipping industry was less than consistent in being environmentally responsible. Lax enforcement of regulations led to the dumping of garbage, solid waste, and oily bilge water at sea. A significant effort toward building environmentally friendlier ships started in the early 90s. Regulations and enforcement increased. The attitude of ship owners and senior managers of cruise ship lines today reflect the shift in attitudes toward the environment.
You know, we do make our living actually from these oceans, and so it's important to us to protect them.
Well, we are far above and beyond any environmental regulations, national, local, IMO, MARPOL and things like that. Yeah. On Royal Caribbean, we are following the green ship concept, which is zero discharge overboard. That's it. No cigarette butt, no toothpick, no chewing gum, nothing is allowed to be thrown overboard. So we are promoting this policy as well to our passengers, and we are advising them, you know, over the P&A, nothing to be thrown overboard and things like that.
For the Eagle ships, RCI management demands the design to exceed current environmental regulations in every area. Between the onboard treatment plants and holding tanks, this should be the most environmentally friendly cruise ship ever built, despite its size. Newly designed oil-water separators are a critical part of the planning, as well as more space for holding, compacting, and incinerating waste. Final system design and testing will be needed to see how well the environmental engineers have done their job. The critical designs are done. The huge dry dock holds another ship, soon to be launched, making way for the first Eagle ship, Voyager of the Seas. With steel on its way from the mills to begin the building process, the pressure to finalize plans for each area grows, a process which will continue long after construction has started. From this point on, the team has 104 weeks before the first paying passengers will board the ship on November 21st, 1999. Before that, many thousands of decisions must be made, problems solved, and although they don't know it yet, there will be serious setbacks, including a devastating construction fire which will push schedules and people to their limits. It will eventually take 10 million working hours by men and women in more than 15 countries to complete the design, to build, to test, and deliver the largest cruise ship to ever float, the first of the Eagle class, Voyager of the Seas. 3 years of work, and this is still just the beginning. In the second episode of our story, you'll see how the ship is built, floated, and tested. You will see how the Finnish yard workers cope with the severe cold of the Arctic winter. You will be aboard for sea trials, where every system is pushed to the max, as the Voyager of the Seas leaves sheltered waters for her first venture onto the open sea. I'm Roland Smith. Is Voyager of the Seas. It is the first of the Eagle-class ships, the largest cruise ships ever built. At 137,300 gross tons, it is nearly a third larger than the largest nuclear aircraft carrier. In the next hour, you will see how this ship is built, fitted, and tested. There will be times of triumph. Yes! And dramatic setbacks. We will accompany the officers and crew on the first sea trials, and we will see how they put this ship through the extremes of performance. I'm Roland Smith, and this is the story of the creation of Voyager of the Seas. The Kvarniemassa shipyard in Turku, a small town in Finland's southwest corner, a town where shipbuilding has a long and proud history. Turku, also known by its Swedish name, Abo. It's quaint and quiet. In summer, when the sun literally never sets, people enjoy the parks, the river, and the surrounding archipelago dotted with picturesque islands. In the winter, the river freezes. The saunas are kept warm. There is light for only a few hours each day, and it's cold. So cold, in fact, the seawater actually freezes more than 1 foot deep. Turning the idea of a big ship into a big ship is a tribute to the talent, ingenuity, and collective intelligence of thousands of people worldwide. Already thousands of hours and hundreds of meetings have taken place in the design and planning process. 28 architectural firms from around the world prepare drawings, renderings, schematics, and blueprints, which the yard architects must then review and often modify to make them work in the ship's total layout. Each area of the ship is assigned a specific design and engineer team who monitor their area throughout the construction process. It has been over 3 years in planning. We begin this part of the story on a cold, wet morning on the edge of the shipyard. Raw steel sheets from the mills in the north are brought into the yard. These sheets will be the first steel to be cut, to to become the parts for the hull, decks, and structures. As the steel moves inside, it is sorted, marked, and it begins its journey to the ship. One of the many Finnish shipbuilding traditions are ceremonies to mark milestones in the birth of a ship. Every major step in the process will be celebrated with a ceremony. The steel cutting ceremony is telecast by satellite to a group of top travel agents gathered in a New York restaurant.
Hello New York, hello Richard, and you are all warmly welcome to a short visit in our yard here in Turku, Finland. And we are very well prepared to start the work on this big project, our new building number 1344.
The marketing effort has also officially begun.
This is the place we start. And here is the double bottom section, of which the two parts belong to. And these are the longitudinal keels you can see here, these two plates. And they are now situated here below the steel cutting machine.
Cutting the first piece of steel means the ship has truly begun construction. These plasma cutters are computer controlled and cut precisely through inch-thick steel like butter. They operate at 22 to 25,000 degrees centigrade. The cutting is all done underwater. The water cools the surrounding steel and keeps the intense heat from warping the metal around the cut. The cuts are checked and the pieces marked with a number and a drawing which will stay with this plate all the way until it's in the proper place in its part of the ship.
This is done.
All the parts are pre-assembled. They come together Lego-like. By the time it's done, there will be in excess of 300,000 steel pieces. No one will ever know the true number, since many pieces like small supports are made in large numbers and used in addition to the parts in the drawings. Without the detailed plans, it's impossible at this point to know what you're looking at. Most of the blocks are built upside down. It's far easier to install the plumbing, wiring, and even air conditioning units and ducts in the ceilings. Here, Captain Olaf Neister, along with the construction supervisor for this block, the foreman, and the official inspector for the certification agency, Det Norske Veritas, go over every weld and component.
You have to inspect the small pieces before they become large pieces. This is the top. This will be, of course, white painted and so forth. And the deck will be up above. So when you're inspecting steel sections, you have to bear in mind they are turned around. Right, everything's upside down. Right here, it's a very weak point. So they have to put on some brackets, some stiffeners.
Structurally, the ship is quite sound, as designed. The added reinforcements do have an effect in cutting down on vibration and stiffen and strengthen certain areas even more. It is far easier to add them now than later. And the process goes on for every brace, every plate. Over 300,000 pieces of steel to cut, fit, and weld. The reality of just how big and how much more there is to do, more than anyone imagined, is just beginning to sink in.
I think the short building time is a key. We are, it's stressing us and it's stressing the art, surely. And that will be something that will be, I think, most of a challenge during this period, for us and for the art.
This tunnel bored through solid rock allows vehicles to enter the huge dry dock. Placing the first grand block, which by itself weighs in at over 600 tons, marks the point at which the ship will be assembled into a form we will soon recognize. A Finnish shipbuilding tradition is to place coins minted in the year of construction under the first block. Later, when the ship is floated out, they will be retrieved and put on display. Despite the bitter cold of the winter afternoon, spirits are high as the first block is carefully lowered into place.
Yes!
The exact placement of the block on the concrete and wood supports is critical. So critical, lasers are used to measure distance and position. This is the center of the ship, and the rest of the blocks will be built out and up from this point. A slight misalignment here, and the ship may not fit into the dry dock when they get to the ends.
To give you an idea of how large this dry dock is, take the Empire State Building, knock off the antenna, the television tower, and another 50 feet, and you could put the Empire State Building from that end to that end of the dry dock. That ship, when it's finished, will fill this lengthwise.
The first blocks to go into the dry dock have the tanks and pipe fittings already installed.
And then there is also a wish to have more pattern.
At the same time, the interior designs are coming together.
To this level.
This is the most comfortable chair that you can play cards in that is also stackable.
Then you've got the tee, you've got the golf ball.
We have 5 different colors.
You mean the 5 different stools are 5 different colors?
Yeah.
On purpose?
On purpose, yes.
The construction continues through the winter as more and more recognizable sections take form. This is one of 2 specially built trucks which carry the huge blocks from the assembly buildings to where the 600-ton crane can lift them into the dry dock. Every set of wheels in this machine turns, and the entire vehicle hydraulically squats to move under a block, then lift it. This is half of Studio B, the theater, television studio, and ice rink all rolled into one. The form and structure are becoming recognizable, where the audience will sit, the arena, and so many details to be finished in each block even before lifting, like insulation and plumbing.
This is, the stage is these are lifts, is to get use the sets and production values here for the ice rink and to get the skaters on and off the ice. So we've constructed ramps made of glice, which is a plastic kind of ice, so they will mount stairs here and skate in from these areas. Well, the first half of the show is a international ice skating spectacular, complete with flying using the Foy flying rigs. So we'll have skaters flying a la Peter Pan.
Flying even higher than the ice skaters, these blocks of steel are carefully lifted into position. Similar to the connected floors in a modern skyscraper, each block of the ship derives much of its structural integrity from the pieces around it. So when it's lifted, it is not anywhere near full strength. Lift it the wrong way, and it could bend, crease, or even collapse. Interestingly, many of the crane operators are women. According to a yard supervisor, women operators often have a better touch with the cranes and cause less damage. In his words, they are more patient. The big lifts are complicated and dangerous. Too much wind and work has to be halted. Crews have to guide, position, and secure each section. Tricky work, standing high atop steel in the cold wet of the Finnish winter.
The maximum weight of one grand block is 600 tons. That's the maximum that we can lift at one lift into the building block.
This huge block, built upside down, has to be turned over before it's moved into position. It's big, heavy, about 500 tons, and rotating it is tricky and dangerous work. Fortunately, no one is allowed underneath during any of the big rotation lifts. Voyager will need 6 huge diesel engines to drive her generators. The Wärtsilä engines are chosen for their reliability and the fact that the factory is in the city of Turku. Each diesel has 12 cylinders and is rated at 17,140 horsepower. In its parts and pieces, these precision machine giants are more like works of art than machines designed to work around the clock, year after year.
We have so many new things. We have so many new pieces in the puzzle, so that we wanted that in the areas like the power plant, so that we concentrate on a solution which is well proven. That's why we went for the diesel engines.
Each is built up and must undergo rigorous power runs and adjustments at the factory before they are ready for delivery to the ship.
We are amazed about actually this power station. It's so stable, always running with several engines parallel there. I'm really surprised about these diesel engines. They go from 0 to 100% in just 28 seconds. They just pick up the load in 28 seconds up to full load from an idling engine.
Bigger than a bus and weighing 185 tons, each diesel engine arrives by barge from the Wärtsilä plant in Turku, just a few miles away. They must be hoisted into position before any block can be added above them. All the essential plumbing and piping have been pre-built into the blocks. It's quite an achievement that so many components built in different parts of the world come together with remarkable precision. Eight months of assembly and lifting becomes a ballet of cranes, steel, and workers, captured through the magic of time-lapse on a scale so grand as to defy the senses. The 29 elevator shafts are built on shore, then lifted into position in one piece. The first shaft is hoisted, ready to go in, but the lifting points are not correct. It doesn't hang straight, and with the tight fit, it must be exactly vertical. It takes nearly 3 days to get it right, but now the technique is perfected and the other shafts will go in far easier. The tolerances are very tight. Placing a shaft this long into a narrow opening down 14 stories is no easy task. The precise alignment of huge blocks has been near perfect up to now. Halfway in, this one jams. The men consider the options. Force it too hard and the shaft may bend, causing delays and repairs. Work in this area will come to a halt until a solution is found. The foreman comes up with an answer and the men move to all levels. A few wedges plus some well-placed slams of a big hammer, it finally slides into place. Each cabin is pre-assembled with plumbing and electricity, even cabinets. Marked for exact deck and position, covered with clear plastic, then black plastic, and shipped back to the yard.
As today is the 1st of April, we are now in good progress with the production of cabins. The production is in full speed. The largest challenge for us in the cabin factory in this project is of course the size, the huge size and tight building schedule of this project.
There are nearly 2,000 miles of wires in Voyager, and every one has to be laid in, connected, and checked. It's a huge job, which will continue all the way through to delivery. The isopods are attached while the upper section of the stern area is still open. The thickness and design of the steelwork in this area is far more massive than other ships. The huge bronze propellers are made in Russia. They are manufactured in a factory which used to make propellers for Russian submarines.
The old propeller shafts are gone. We're going to have 3 pods where the pod actually hangs underneath the vessel and holds or encloses the electrical motor which will be propelling the vessel. The one in the middle, the center line, will be fixed and it won't be movable, but the 2 on either side will be azimuth pods, meaning that they can rotate actually 360 degrees.
The 4 bow thrusters have more power than the ship Song of Norway has for its main propulsion plants. They are 11 feet in diameter and have reversible props. The electric motors are rated at 4,000 horsepower each.
We have simulation tests at this point that are indicating that the vessel will be fully maneuverable and up to 40 knots of wind, which is almost unheard of.
Operated by hydraulics, the 4 stabilizers are extended at sea to minimize the ship from rolling and keep the passengers from getting seasick. They are retracted in port so the ship can dock. Inspections continue by the yard, the certification agency, and Royal Caribbean. The certification agency will spend 6.5 man-years, that's over 10,000 hours, inspecting the ship during construction and sea trials before she is certified to carry passengers. From the beginning, there has been concern about the atrium fire doors. Both the United States and Norwegian authorities demand extensive testing to prove the design will actually work when the ship is moving and rolling. The uppermost decks are made of aluminum, not steel, to preserve stability. Today's ships are welded, not bolted or riveted together. Welding is far stronger and waterproof, but steel does not weld to aluminum. In order to join the top structures to the steel decks below, special bonding plates have to be made. A piece of heavy steel and aluminum are brought together under high pressure and in a vacuum. With an explosive charge between them, they are literally exploded together, resulting in a single piece of metal with steel on one side and aluminum on the other. It is literally an atomic fusion of the two metals in the middle. The process is called blast welding.
We are in the forward part of the vessel, up on the sun deck, and what we see here is the aluminium and the steel joint. We use a lot of aluminium on top of the vessel to save weight and to get the center of gravity down, to have the light material on top and the heavy material down, and we get the center of gravity down and good stability for the ship.
The final major block, the aft stack structure, is moved into place. It has been a wet and cold week, and the top of the ship is coated with ice. It's over 200 feet up, and this work is getting dangerous. Finally in position, the block is close, but the cold has affected the shape, and it does not fit into the attachments. It takes a sharp eye and brute force, but finally it is in position, ready to be welded. Voyager is nearly ready now to float out. Some of her systems are being tested, tanks and valves are checked and double-checked. Accidentally flooding a compartment during float-out would be very embarrassing. It's the day before float-out, and preparation continues. Water will be let in slowly through these giant valves, gently lifting the huge ship off the construction blocks. Thousands of gallons of water will be pumped into ballast tanks aboard the ship. The calculations must be very exact because the ship must lift off the blocks evenly. An uneven lift, front to back or side to side, would put enormous weight on one small section, and it could cause hull damage. The ceremony to open the valves is held in the late afternoon. With only 6 hours of sunlight, it's already dark. There is a crisp Arctic chill in the air, but the excitement builds as workers and executives gather.
We're doing well, guys. Put your back into it.
The ceremony over, engineers and workers will watch through the night as the water flows in, adjusting ballast as the giant ship begins to float for the first time.
Watertight net inspection at about 9 o'clock in the evening, and the water level is 3 meters up along the ship's side. We are inspecting all the bottom tanks and the lower part of the engine room. We are down in the double bottom level, checking that everything is watertight.
It was very interesting last night watching when the water first started to touch the hull. It was like the water met something where it was supposed to be and where it belonged. This is absolutely the moment she is born. This is when she is coming to a right element. Even if she started in April, she was not really born. Today she get her soul and she is where she belongs. Absolutely. Very exciting.
When the water level equals the level of the ocean, the end of the dry dock is removed. Ever so slowly, the ship is eased out and moved the 1,500 feet to the fitting out dock. The first order of business at the fitting out dock is to connect electricity and heat from the shore. Winter is a brittle time in Finland. The cold moves into everything and stays there. Ambient heat disappears in moments, and despite the constant freeze, construction continues, with over 1,000 workers on and off the ship each day. Just the normal process of construction creates a potential hazard, even though safety precautions are taken. Precautions are only that, precautions. Mistakes and accidents can happen because unforeseen conditions combine into explosive potentialities. On Friday afternoon, February 19th, what is feared might happen does. A welder working on a section of infrastructure is unaware that the showering of his sparks are falling near barrels of highly flammable fluids on the other side of the bulkhead. The fire on Deck 1 quickly spreads to construction materials stored in what will be a food storage area. The welder discovers the fire and sounds the alarm on a temporary system. He makes an attempt to put it out with an extinguisher, but the fire has already grown too large. The amount of smoke leads everyone to believe at first that the fire is much larger than it actually is.
So here you see the difference between that side where the fire started and then the other side where was only one fire door fighting against the fire.
The fire was rather small but destructively hot. Some interior bulkheads, deck plates, and one main support must be replaced. A task that is time-consuming but not difficult. The setback weighs heavily on everyone, and the disappointment is evident on morale. The challenge now is the clock. Delay, a prospect that is costly to both the owners and the yard. It is now March, and time is the enemy. The contract is rewritten to reflect a new schedule, moving delivery now to October 29, 1999. It is unknown if the yard can even meet the new schedule. Any extra time they did have is now gone. 2 separate sea trials are rescheduled into one. Not much time for all the finish work, crew training, and crossing the Atlantic. Work on the remainder of the ship continues. The thousands of wires, connections, and systems each have to be connected and tested one at a time. The delays have a ripple effect as everyone must adjust to the new schedules. As each area of the ship structure is finalized and inspected, the craftspeople begin to come aboard, working their magic in tile, mosaics, fine woodwork, and finishes. Little by little, the adornments and parts which make up the spectacular interiors begin to emerge from the steel. And as soon as they are finished, they are covered and protected from damage as heavy work continues around them.
But it's the proportions are just terrific. You really get a good sense of it.
And the extra width what we worked here, the extra 1 meter.
That extra 1 meter
That extra
was,
1 meter,
was
I
well
think
worth it.
was really well.
1 meter makes a lot of difference. And
Where is the meter?
well, it was going to be 8 meters, and we kept insisting it be 9, and they found a way to, and you can see it's actually, the bottom decks are 8 meters apart, 9 meters apart, and the top ends up being 8 meters apart, so that's why it slopes in a little bit. And that extra meter just makes the space so much more balanced, so much more human scale. I love it.
The promotional tour, which included England and New York, is canceled. It is a serious blow to the sales effort.
When it comes to sales, we are extremely dependent upon the travel agency distribution system to find our customers for us to close the sale. So the sales organization here at Royal Caribbean domestically is spending almost 100% of its time working with travel agents on all sorts of issues and helping them to do their marketing, which tends to be very much on a local or regional level.
Sea trials are at a time when the ship systems are brought up to full power for the first time. There are literally hundreds of tests to be completed, and there are also craftsmen on board, working on everything from tile to wood to cabin finishing. A total of 350 people board the Voyager in the Turku yard starting at 6 a.m. on Tuesday, June 29th. There are technicians, workmen, managers, a galley crew, a nurse, 5 captains from Royal Caribbean, plus specialists in every area. A large crew from the yard and inspectors from the ever-present certification agency Det Norske Veritas, they're all on board. They must sign off each major test before the ship can be certified. When the ship leaves the yard, 4 tugs are used to move the ship through the narrow and shallow channel. A huge crowd is on hand to watch as she puts to sea for the first time. The first test is anchoring, making sure that if the ship becomes disabled, the anchors work. The engines are brought online, and the ship finally begins to move of its own accord. One tug follows the ship on standby for the first 3 days, just in case. After just a few hours, the first trouble shows up as a fault warning sounds on the starboard azipod. The warning on such a critical system is taken seriously, and the ship is stopped until the problem can be found. It is the first of many delays in the testing process. The propulsion system starts with the big diesels, which drive generators. The electricity from the generators then goes to a huge power switchboard. The power goes into giant transformers, where it is split into the right voltages for use on the ship and for propulsion. The electricity for the propulsion then goes into a cycloconverter, which controls the azipod's speed direction and power. From there, the electricity goes to the pod electric motors, which turn the propellers. The problem was on one of the control cards in one of the 3 cycloconverters. The fault was on an integrated circuit smaller than a thumbnail. A new circuit board can be brought from the yard and installed. There are no spares on board, so a whole new card is borrowed from the second Eagle ship, Explorer of the Seas, now under construction in the dry dock. 8 hours later, everything checks out in the master control room, and the trials continue. The automation and autopilot systems, some of an all-new design, are put online for the first time, and they function perfectly. Captain Akusti Kovalainen, much like a test pilot, is in charge of sea trials, and he is impressed. The bridge is the largest ever built. Its control areas look more like a scene from Star Trek than a ship.
You know, that's how it looks to me too. It's like Star Trek. It is very much different from the way I have been used to do it. I've never sat in a chair to do all my work from the bridge.
As the captains put the controls through test after test, everyone is clearly amazed at how well the ship handles. Speed is one critical test. The ship must achieve a certain cruise speed at a given power setting, or the yard must pay a penalty. During the speed test, the pressure and tension is obvious.
The official speed they have to calculate and correct for the power and for the water depths and for the waves and the wind and for the draft, displacement, water temperature, density. Lot of corrections. That takes a little bit of time.
The contracted speed, which must be met, is at 75% power, not full power. Speculation about what the top speed will be is debated all over the ship. A pool has been started to guess the speed, and the official results will be announced later in the sea trials. Captain Pedersen is even in on the pool. His reaction after one of the speed runs is telling.
My guess was slightly above 23 knots. However, it seems like now it will be slightly above 22. I'm not disappointed in the speed, I just made the wrong guess. It's not official yet, but the speed was 22.77.
Very, very
so the speed will be around between 22.3 and 22.5 after it's corrected. So that's better than anticipated.
Yeah, she's doing very well. Magnificent.
Captains Pedersen and Favelin experience how good the azopods are for the first time.
You know, from what I have seen since we left the pier on Tuesday morning, it has been handling much better than we ever could have thought in advance. She is doing so well that she is like a small yacht when it comes to handling. You can do anything with this ship.
The stabilizer tests require everything on board to be lashed down. The ship is then forced to start rolling up to 5 degrees side to side. Then they engage the stabilizers and see how quickly they steady the ship. The tests are repeated at different speeds for several hours. All the elevators are turned off during the test as a precaution, and the 10 stories of stairs from the bridge to the master control room gives the men checking out the system a real workout. As the ship is rolled to one side, then the other, you can see what 3 degrees is like. Remember, the ship is certified to survive 45 degrees. But 5 degrees is the maximum for passenger comfort. The roll testing continues for several hours. Everyone will be relieved when it's finally done. At the same time, fire door testing is being carried out. The huge fire doors in the Royal Promenade work well. Only a few adjustments will need to be made to the hydraulics, but in the theater, one of the backstage fire doors simply does not work right. It will take days of fixing and adjusting to get it where these fire doors will be accepted by the inspectors. Every sensor, alarm, and system has to be tested one by one. The engines need to be run at full power and adjusted.
We discovered during the full load tests that some of the temperatures in the, say, the converters, the converter rooms, transformers, propulsion transformers, were higher than we anticipated and not as balanced as it should be. And we found that some of them needs to be adjusted. Those are not major. We have in some other areas adjustments that needs to be made that have a bigger consequence, but it's also things that can be dealt with relatively easily in the time that's left. But it's a job for the art, surely. So, but it's the purpose of this to detect these things, and so that they can be fixed. Because once you leave the yard, forget it.
The days are long, the work never stops, nor do the countless alarms going off. Every fire and warning system is tested over and over. The fire systems are not fully functional. The crew sleeps when they can. The sea trials are now seriously behind schedule. It is announced that the ship will stay at sea at least 2 extra days.
The ship has behaved extremely well, despite that we had all the rush to get everything together. So from the functional point of view, everything has been going very, very smoothly. We have had a little bit hiccups with our measuring tools and with some of the procedures. And then we didn't reserve enough time for the various tests. We didn't remember that the ship is in every respect 50% bigger, and it takes a little bit more time to fine-tune 3 engines rather than 2, and so on. But technically, this is really, from the performance point of view, has been an outstanding sea trial.
The 2 extra days become 5. Every day at sea is 1 less day in the yard where over 1,000 workers wait to continue their work. An innovation on the Eagle ship is what is called the ducktail. It is an extension over the stern.
The intention is to give a better flow for the water when it's leaving the hull, and you basically extend the length of the hull. And that reduces the resistance 3%. 3% every year, every day in the propulsion is quite a lot of fuel. So it's making the ship in consuming less energy, and that has been a part of that. We were a little bit worried in the beginning that if that is going to look ugly from the exterior point of view, but it fits extremely well there.
The wind is blowing at nearly 30 knots, but the day is clear and crisp. Today will mark the first landing of a helicopter on the pad at the front of the ship. This is the first on a cruise ship.
From day one, so what we decided is that we would like to have a good active helipad on this ship. The bow is superior location. I think this is enhancing a lot the safety. We need the helicopters among our passengers, so we have some air evacuation needs 2 to 3 times a year on every ship, so we do that. This is a safe way of doing that.
See if we can do something.
The ice rink testing runs into a few snags.
We also have a special ventilation system for this ice rink room to dry the air, so we don't get so much humidity in here. But that is not running 100% at this stage.
Will the ice crack when the ship leans and turns? That's the key question.
First, we were making it as hard as possible to see if it cracks on the ship. The harder you get the ice, the easier it cracks. But the ideal temperature is about 4 or 5 below 0 Celsius on the ice.
The key element seems to be hardness. Make ice too cold and it becomes brittle. Too soft and it's hard to skate on. But overall, the tests are successful. And in these shots, I joined the Royal Caribbean and Cabernamassa people for the first ice skating at sea.
How good? A little rusty, but I'll tell you, it's a unique experience to be skating on an ice rink in the middle of the ocean. Whew.
Low on food, fuel, and supplies, and with all major tests complete, the ship turns toward the yard. The pressure is building in the race to finish and deliver on time.
Through the long Arctic winter,
faces braced against the bitter cold. They lift, they shape, they build what man has never seen before. Into cold steel they breathe heart and soul. From their hands a great ship is born. So many different faces, pride and joy along the way. These are the faces of the unsung heroes behind the scenes every day.
In part 3 of our story, you'll see how this city on the sea comes to life. We'll go behind the scenes to see how the shows are put together. You'll experience Voyager's momentous crossing of the Atlantic, and you'll travel aboard for her maiden voyage. I'm Roland Smith. Project Eagle. The challenge is to design and build the largest, most technologically and environmentally advanced cruise ship in history. The melding of steel, electronics, parts, and crew is nearly done. It's close, but numerous delays have caught up with the promise of the ship's delivery, and there is much more than finishing touches to do. It appears that nearly everything is behind schedule. Tensions run high. This will be a race to the finish. Hundreds of workers will stay on board for the Atlantic crossing. I'm Roland Smith, and in this concluding episode of our Voyager story, you will see how this city afloat comes to life. Voyager of the Seas is just a few weeks shy of leaving the shipyard in Finland for the final time. She passed her sea trials with only minor mechanical work to be done, and is now poised to make her way to her home port in Miami. But there is still an unexpectedly large amount of work to do. The devastating ship fire and many other unforeseen complications have thrown into question whether or not the ship will be finished by the time it reaches Miami. In an effort to catch up, the shipyard calls in reinforcements, and the pace of the work intensifies. The only thing that is certain is that there are nearly 3,000 passengers already booked on her maiden voyage to the Caribbean. The countdown has begun. The shipyard isn't the only place where people have been fighting deadlines.
In the route 2, 3, 4, 5, 6, 7, 8, 1, and then we're...
For several months, director Mark Dow and his team of choreographers, vocal trainers, actors, and technicians have been creating original productions for the 1,350-seat La Scala Theater.
I'm sure I started working on this easily a year and a half ago from this point. So it'll really be 2 years from the time we probably really first thought about stuff to the time that it's done.
When you first come out, do give me...
The music is months and months of work. The video is months and months of work. The costumes are months and months of work. And we work 6 days a week, and we work 10 hours a day, and it's all to get the choreography and to get the vocals down.
Mark, a veteran cruise ship show creator, was selected to put the show together.
Start rotating around on the turntable.
The selection process for the performers was very competitive.
If they're an amazing singer, guess what? I can just do this. If they're a mediocre singer, you have to live inside somebody's limitations. Because the truth is, what I do with them is going to only go to their level. So then we do this audition tour that takes us to Chicago, takes us to New York City, it takes us to Sydney, Australia, and it takes us to London. So we pull people literally from all over the world. Get the best singers, get the best dancers, and what you end up with is this United Nations cast.
1, 2, 3, 4, 5, 6, 7, 8.
Meanwhile, on the other side of the country in Los Angeles, the ice show rehearsals are also in full swing. Theatrical shows have a long history on cruise ships, but the ice team in LA is entering uncharted territory.
We have experience with stage performers, we have experience with dancers, we don't have experience with ice skaters, so it'll be very interesting to see how compatible they are with the ship environment, which is very important, and how they are compatible with the rest of the performers on board the ship.
We've only had 2 weeks rehearsals. This is the first time with costumes, and they have an audience. And I've got new kids in, so it's, you know, people that have never performed in a professional show before.
The performers aren't the only ones being put through their paces. At the Star Center in Florida, the Voyager bridge crew has been undergoing rehearsals of a different sort. The officers, from captain on down, are subjected to an intensive training program in a bridge simulator that is an exact replica of the one on Voyager.
Good morning. Good morning, Captain. My God, where are they? Close to Lavadie. Close to Lavadie. With the range and distance to the mooring board.
I would say it is about 1,200 feet, maybe.
Royal Caribbean thought it was important to create a full replica of the system so that we can train in every aspect of the operations. As far as the level of detail of training, we have modeled every port that is on the Voyager transit, and even though these officers have not taken delivery of the ship, during this 10-day course we would have sailed into every port that's on their itinerary. So they'll be fully comfortable with the procedures of going in and out of those ports with this particular ship and this particular equipment that we see here.
Try to establish a reasonable procedure and checklist for a watch relief for the Voyager bridge.
Creating a training curriculum for a ship this unprecedented in size and technical sophistication was a top priority for the cruise line.
You come through the door, what are you going to do first? What are you going to do second? Think about it may be dark and your eyes haven't adjusted to the darkness yet.
Royal Caribbean appointed veteran captain William Wright to create the program.
The decision was made a long time ago to develop a ship-specific simulation program for the Eagle class vessels, primarily because they were going to be unique in almost every way. Not only the size, but also the propulsion system, the AZI-pods, representing brand new technology for passenger ships. In fact, it's pretty new technology for ships of almost any type. The control systems are going to be different, so I think it was fairly obvious that to man a ship like the Voyager with qualified officers who are competent to navigate her safely, you'd have to devote a lot of attention to giving them the hands-on training for this type of vessel and the specific propulsion systems that she'll have.
Voyager of the Seas, good morning to you. This is a Sealand Achiever.
The simulated scenarios are far more grueling than anything the officers would experience at sea. Behind the scenes, a team of what are called distractors control the exercise by manipulating weather, traffic, communications, and technical problems.
We'll take this tanker and we'll have him come to port. To go around this guy? Yeah, and ask him if he could.
One of the biggest causes of accidents is that people have a great situation awareness when they are relaxed, but as soon as the stress comes up, their concentration comes down and focuses. They get what is called tunnel vision, and that is the cause of most of the accidents. When a man gets tunnel vision, he does not realize what is going on around him, and then the inputs start increasing beyond his capacity to deal with them. 252, 3 mile on your 4/4. Captain, you read me.
Yes, I certainly can. Our position is north 2017.2. Yes, Bridge?
We increased the communications, we increased the targets.
This is Tanker Galileo. We would like for you to stay clear of our vessel.
Bridge, that's Captain.
Go ahead, Captain.
Yeah, I heard something about yellow condition. It's something we should know, Captain should know.
We're really busy up here.
Howard and Roberto were giving them more and more stress till finally it reaches their load limit, their human capability limits, their capacity to handle it. So they called one more person on the bridge. Now we are raising the level up once again in order to keep the stress level up. The aim of this exercise is for them to realize which are their weak points.
So he either has to keep going this way or try to cut in between the two.
What is this one we have on the, that's the one, it's the stop there.
That's in the boat. I have a red light on number 2 and yellow light on number 1.
If you have a target, he identifies
At the end of the exercise, Captain Wright gathers the crew for a debriefing.
You came up, you certainly were trying to help them, there's no doubt about that. But you were involving yourself in every aspect of it, so it was not clear to me who had the con. But that's why we do these training exercises, right? To simulate events like this.
The marketing of Voyager is also in full swing. Pre-selling cruises to passengers without a finished ship to show them will require an innovative marketing strategy.
I'm used to having a sample to market, and this product isn't finished yet. And we've got some real neat marketing programs that we're doing. We have a virtual Voyager experience that we're taking on the road starting the beginning of August, which is a 53-foot semi-trailer that will reach 19 different cities. And in those 19 different cities, people will have a Voyager experience.
4 weeks prior to the departure, Voyager's crew begins moving onto the ship. The hotel, dining and kitchen staffs, technicians, and others were brought over early for orientation and training. Adding 1,200 crew to the already overcrowded ship is creating a situation where everyone is competing for workspace.
You're involved on a work site that has millions of people all actually applying their trades, and you're one on top of the other, and you have to give way, you have to be tolerant.
Progress continues at the shipyard, but there are still deep concerns about whether or not the ship will be ready for the Atlantic crossing. At this point, most areas on the ship still require extensive finishing work. The team installing the golf course works at a furious pace, fighting the clock. Each hold is prefabricated at a factory in New Hampshire and then shipped to Finland for installation. The holes are rolled out onto the dock where they are carefully lifted and installed onto the sports deck. The departure is now imminent. But before the ship will be allowed to set sail, it will have to be certified by the Classification Society and the U.S. Coast Guard, who sends a team from Miami to ensure that the ship conforms to U.S. maritime safety standards. The inspections cover every system of the ship with a primary focus on safety procedures and equipment.
All right, good, that's fine. You can cut that.
It is now 24 hours before Voyager of the Seas is scheduled to leave Turku. It's been decided that several hundred additional workers will have to stay on board for the crossing to continue unfinished work. There is no other choice if the ship is to be ready for her maiden voyage in 3 weeks. Before she can leave, however, the shipyard must officially turn over possession of the ship to Royal Caribbean. There are 3 aspects of the handover. First, a temporary safety certification, valid only for the crossing, must be approved and presented to the cruise line.
These are the key documents. This is what really counts. Okay? This says we've been checked a few hundred times to make sure we comply with a few hundred rules and regulations.
Next, more than $250 million, the balance due for the ship, must be transferred from Royal Caribbean to the shipyard. Last-minute negotiations stall the contract signing.
Whenever we go through one of these things, it's always, you're down to the last minute, you think you're there, It should be over. Now I'm just ready to do it. Now we're sort of standing around and waiting, and there's nothing terribly important that seems to be happening, but we don't own the ship yet.
The contract signing is delayed for several hours while the cruise line and the shipyard hammer out who is responsible for the remaining work. At last, the papers have been signed and the funds transferred.
So, thank you, Richard.
Congratulations.
Thank you.
Well done. Congratulations.
Thank you.
Now, of course, the event must be commemorated in a fashion befitting the Finnish love of ceremony.
Are you prepared to take delivery?
Yes, we are, with pleasure, happy to take delivery.
Lower the flag of Finland and the flag of Väinämössä yards.
Ankkurit nostakaa, maa jäädä saa. Jos pilvet taivaan peittää, aalto hurjin laivaa heittää. Aina on huoleton, maa jäädä saa. Jankkurit nostakaa, jo aamutuuli purje pullistaa.
Voyager now officially belongs to Royal Caribbean. She is scheduled to depart in the morning. But a last-minute decision is made to postpone the departure from Friday evening to Sunday morning to ensure that the ship has all the necessary supplies on board to complete the unfinished work.
Seems to be all right. Doesn't move.
The day has finally arrived. Voyager of the Seas is now poised to leave her home and make her way across the vast unprotected waters of the Atlantic.
Seems to be coming up.
In the pre-dawn hours of a cold October morning, Captain Pedersen gives the command to Staff Captain Zini to slacken the lines.
The stern, at this time you can let go the press line.
As Voyager pulls away, Explorer, her sister ship, will soon be floated out to dry dock to take her place at the finishing dock, and the process will begin all over again. Assisting Captain Pedersen is senior port pilot Kuvalainen. Kuvalainen acted as captain during Voyager's sea trials. Because of his familiarity with the ship and the local waters, he is the natural choice to assist Voyager's officers in navigating the tricky waters of the Finnish archipelago.
We left Turku 7:56 local time.
The captain eases Voyager away from the dock.
All lines are clear.
Because the water at the dock is so shallow, a fleet of tugboats is used to tow her out to deeper water, where she'll then operate under her own power.
30 meters off, but
15 meters or 20 meters from the ground.
Speed is decreasing.
Despite the early morning departure and the late autumn chill, the townspeople have turned out to bid her farewell.
I have decided to go a more southerly route, and I expect to have fairly good conditions all the way across. It's important for us to have good conditions. About 1,050 of our people, they are not necessarily seamen, they are hotel-related people, and the motion of the ship could affect their work and training very much.
The captain has carefully selected a route that will take Voyager from Finland to the Baltic and North Seas, through the English Channel, where she'll pass into the Atlantic Ocean. She'll sail through the Azores and then make her way across the open ocean toward the Bahamas to her final destination, Miami, more than 6,000 nautical miles away. Work is proceeding, but it's become apparent that more workers and parts are needed. Off the coast of Denmark, Voyager rendezvous with local tenders to bring aboard additional workers, tools, and materials. It's a process that she will repeat 2 days later in the English Channel. En route to the Channel, Voyager will face an interesting challenge, passing under the Great Belt Bridge.
It is very important that we pass the bridge in the center of the bridge. If we come too far out on either side, we will not have the necessary clearance and will be, of course, stopped.
The Great Belt Bridge, at its highest point, is 210 feet. Voyager's highest point is 214 feet. So the captain must ballast the ship down in order to pass safely under the bridge. Captain Patterson orders 18 knots of speed, which lowers the aft area even more. She squeezes by with only a few feet to spare. Work continues all over the ship, on every area, at a hectic pace. During the crossing, much attention must be focused on safety training. Royal Caribbean safety officers will devote their energies on extensive fire and rescue drills.
As we go down, how much less it is? We fight fire, number 5.
Today we're looking at the mobile group training, and our mobile groups are our firefighters on board the ship.
Let's go down on the deck like we normally would for fighting fire. You go this way to get there.
We have 7 of those groups on board. We take them one at a time, and today it's our mobile group number 3, and we're going through hose handling techniques. We're showing them the new nozzles that we have here on Voyager of the Seas, and they're practicing advancing on fires, retreating from fires, and we're going to advance from there. They're all old hands, they've done this before, but not as teams. So basically what we're doing is team building. You're going to have to adjust that yourself.
Cutting-edge technologies like these high-tech fire helmets have added a new dimension to onboard fire rescue.
Stay low, make your entry.
The helmets, which cost about $25,000 each, allow the rescuer to see a victim through thick smoke by using thermal imaging technology.
The engine spaces.
Royal Caribbean brings in experts to get the fire crew up to speed, because mastering this technology requires in-depth training.
Now, what you do is, between your thumb, once you have the V in your sight, the thumb and your fingers, you want to line up whatever you're trying to grab inside that V.
You're going to make a search, go in through the door, do a right-hand search around the compartment, okay? Inside there is a hot water bottle about that big. I want you to bring it out, okay? Can do.
The true test of fire readiness is the Bravo drill.
Nice and low for now.
Safety officers, without any warning to the crew, create a simulated fire emergency by placing smoke generators in undisclosed locations. The smoke triggers sensors that alert the bridge, which is the tactical command post. The captain calls the shots by first dispatching officers to verify the location and the scope of the fire.
Okay, the safety officers on the way, close all the doors on the area.
The captain then scrambles the mobile groups by using the ship's general PA system.
Bravo, bravo, bravo.
All mobile groups, report when you're ready at your stations.
Message to all employees, this is a full emergency bill. Full emergency bill. All officers step into your emergency station.
The fire doors and the watertight doors are closed, and a general alarm is sounded. This is the cue for all passengers and crew to don their life vests and report to their muster stations.
972. Yes, right here. 1268.
The mobile groups, meanwhile, put on their gear and report their status to the bridge.
Proceed to the forward lobby on deck 5. That will be the station area.
The captain dispatches each mobile group to a strategic position to fight the fire.
This is the bridge. They're on their way right now.
All 5 doors closed down. From deck 11 down to deck 2. Mobile group number 6, they are ready.
Because there is no room for error in a real emergency, the trainers cut the fire crew's little slack.
Go up, out. You don't have a leader. We're going in now, we're going to stay where you are.
Hands together or there, and we drag. Don't waste time for stretchers. He needs air quickly.
And as he crosses over, yes, in the middle. Okay, it's a very dodgy one to do. Yeah? Okay, now you've got access.
At the conclusion of the drill, the officers and mobile groups gather for a detailed debriefing. This was the first run-through for the Voyager crew. They will have to do it over and over until it's perfect. The U.S. Coast Guard will give them their final exam in Miami.
It's unrealistic.
Uno, dos, tres, cuatro, cinco.
Testirühm 7, testirühm 7, 1212.
On a typical cruise, Voyager will serve between 15 and 20,000 meals a day. The majority will be served here, in the 3-level main dining room that seats almost 2,000 people. It requires tremendous organization to run the largest dining room afloat.
And the waiters will be responsible. So that means once the station is clean, I want the waiter to check with the head waiters. Any question? Is that clear? Those of you, the assistant waiter.
The maitre d' spends the time during the crossing getting the dining room and his multinational staff up to speed.
It's a lot of training that goes behind the scenes. We have to train before we open. We did ask for the volunteer first, considering it's a big ship. And then we have hand-picked people that we need, like experienced people, different languages, 4 or 5 languages. So we do need this kind of people because we have an international guest. So we have to be able to communicate and wait on any guest that comes over here. That's important.
So now, don't you listen, 2 per mirror, or 2 per.
Fine dining is the quintessential experience in cruising. The cuisine is expected to be gourmet. This is a considerable challenge for Voyager's kitchen staff. The kitchen staff during the crossing prepares meals for the rest of the crew as if it were a real cruise. Feeding close to 5,000 people every day while maintaining quality is a daunting task and one not taken lightly.
We are all in total 210 members in the galley working for everything. So it's quite a lot. Of course, we have a 24 hours operation, which includes the room service, and also the Johnny Rockets will be open for 24 hours. We do cook everything fresh here on board every day. Nothing is pre-cooked. We're starting in the afternoon to prepare everything for the dinner. So we try to keep everything fresh as possible in the last minute to bring out. This makes the product very fresh, and also it is a guarantee for us to have the best taste.
For the dining room staff, Voyager's immense kitchen and dining area will mean plenty of exercise. The food is stored below decks in a series of large refrigeration chambers. Enough food is brought on board to last for the Atlantic crossing, which is about the same as a typical week-long cruise. More than 500,000 pounds of food and beverage, including 20 tons of beef, 28 tons of vegetables, and 70,000 eggs. Of course, the unprecedented amount of food and passengers presents a rather large waste management issue. Everything that is recyclable, glass, aluminum, and cardboard, is sorted and processed. Voyager has a state-of-the-art sewage treatment plant on board and has created the position of environmental officer to monitor systems and enforce regulations. Voyager was designed to exceed all international environmental standards. All cruise ships discharge processed water back into the ocean. The water discharged from Voyager is treated until it's almost the equivalent of distilled water. Voyager creates all of its own fresh water. 3 onboard desalination plants produce more than 500,000 gallons of fresh water a day for use in everything, from laundry, kitchens and cabins, to jacuzzis and the ice rink. The quality of the water in making the ice for Studio B is a critical factor because of the risk of cracking from the natural movement of the ship. There is no blueprint for an ice rink at sea, and it was difficult for designers and engineers to predict just how the ice would react to an unstable environment.
Everything is moving, bending, contracting, shaking. On top of that, we make ice, which should not break. On top of that, we have a floor system that shall host many different events, from rock and roll parties to basketball. And on top of that, we have this here, which is a telescopic seating system. One of the problems we have had is that we have not had the patience to follow the proper routines when bringing the floor out on the ice. The floor is warm, and when you put a warm thing on the ice, it will melt into the ice. And that happened with this floor system. We didn't have the patience to wait, cool down the floor until the proper temperatures were reached. That's happened a week ago, and the floor simply got stuck, froze into the ice.
The ideal temperature for the ice is 19.4 degrees Fahrenheit. Because the rink is situated on a lower deck, it is constantly subjected to heat from the areas surrounding it.
Literally, we are making ice on a frying pan. We have a corridor under the ice where you have steam pipes. You have sometimes a temperature up to 35 centigrades. We have an engine room producing a lot of heat. It's not so easy to make ice on top of all that heat.
The ice is holding up well, but unfortunately, that's not the case for some of the skaters. Voyager's course takes her directly into the path of an oncoming storm front and heavy swells. Ordinarily, the horizontal stabilizers would be deployed to smooth out the ride, but they also slow down the ship, something that Voyager cannot afford at this point. The motion of the ship takes its toll on the crew.
Well, they were sick for the first 3 days. I had a bunch of green girls drinking Sprite and eating soda crackers. They'll get their sea legs.
5, 6, 7, 8. Lena and Val, 2, 5, 6, 7, 8. 1, 2, 3, 4. All right, one more time.
We're not taking it easy out here because we're on a ship or copping out because we're on a small surface. We're going to go for it and give you the tricks and give you that athletic element.
My first thought was how anyone was going to skate. And the first day was a little strange, but you get used to it and you learn to deal with it. The worst part is not necessarily jumping or spinning, because you kind of expect it then. It's when you're just standing there and you're off guard, and the next thing you know, you're into the boards or on the ice.
Further complicating matters for the ice show is a risky flying sequence. The skaters, suspended by a remote-controlled wire harness, are flown across the ice as part of a routine. During a rehearsal, one side of a harness breaks loose, leaving the skater dangling precariously. Her fellow skaters rush to her aid. She is shaken, but returns a few minutes later and continues the rehearsal. Technical problems and the unfinished state of the entertainment venues plague both Studio B and La Scala Theater rehearsals. Construction delays have thrown production schedules severely off track. The show staffs are working on very little sleep. The strain begins to show.
The clock is ticking. 1 week from today, we're in Miami. We're in the middle of the ocean, and it's making a lot of us sweat a little bit.
The only way to really do it was to start a 24-hour schedule on the 15th of October. And we got here on the 15th of October, and not only wasn't there a 24-hour schedule available, the shipyard was still building in the theater every day between 7 a.m. and 7 p.m.
Tempers are getting a little frayed here, and people are getting a little more demanding. When someone tells me reasons why we can't do something, I said, that's not good enough, we have to get it done, find a way to do it. I don't have to hear what happened or why you can't get this key or why that light doesn't work. Just figure out a way. That's your job, man.
We're late easily by 7 days late. And this particular show that we're working on now, Rhythm and Rhyme, it's a Broadway show. So as far as lighting, this show is not going to be really hard to tweak.
All right, guys, let's go. Places.
What's going to kill us eventually is the next show, Dreamscape. Dreamscape is really textured. It's going to take a lot of time to cue lighting-wise to be able to make it match the choreography and the music and all that stuff. So I feel a little pressure right now.
The highlight of Dreamscape is the Silk Act, a risky flying routine where the performer is not secured by any safety harness or cables.
Where they're lifted straight up into the air, they do all these really strong poses up in the air. Finally, they literally just shoot out over the audience, out over the first number of rows, and at the end, literally fly above the audience and it flutters behind. It's beautiful. It's really hard, and it's kind of dangerous. There's nothing in that fabric except for the fabric.
The days of the old-style wheelhouse are long gone. Computer-based navigation and monitoring systems have revolutionized bridge operations. Wind, currents, traffic, and navigational data are continuously monitored. A complex program interprets the data and determines the course. The officers on watch check the displays and verify the accuracy of the information.
What you see right here is the Voyager management system. It's a computer-based means of planning or chart work on computer rather than on paper charts. So in here we have all of our electronic charts, and then fed into here is all of our sensors for our position, our compass, our speed, and we're able to do all of our planning and our navigation on the computer screen.
Computerized control from the bridge isn't limited to ship navigation. Officers control a myriad of functions throughout the entire ship.
This screen here is our, what we call our MOS screen, our main automated system screen. It is basically a monitoring system. It's fed into sensors throughout the ship, and it can tell any multitude of things from our propulsion system, our bilge, ballast, and heeling controls, fire system, diesel engines, our air system, so you can fill and dump our swimming pools from here, power management of your main engines, and many other things.
There's no doubt that advancements in technology have made cruising safer. But is safety compromised by over-reliance on automation?
If we lost all of our power and or all of our computer capabilities, we still could use, we have magnetic compass on board still, and we have a sextant, and we would be able to continue a voyage even if we lost all of our electronics.
Separate from the world of paying passengers is another hidden world, that of the crew. Most of Voyager's crew are only allowed access to passenger areas when they're on the job. However, during the crossing, when off duty, the crew are encouraged to experience everything aboard just as the passengers will. The restaurants, shows, spa, bars, even the casino. Additionally, Royal Caribbean has dedicated an unprecedented amount of space for the crew.
There is more gross tonnage dedicated to the employee environment on board the Eagle ship than the entire size of the first ship that this company launched, which was the Son of Norway.
Voyager has a staff assigned to focus specifically on matters relating to crew activities and morale. 1,200 crew from more than 50 different nations make the job challenging.
Basically, there are several roles that I perform. First, I inform the crew of what's happening throughout the ship and throughout the fleet through a crew's compass or through information offered on the crew television station. I also offer counseling and guidance for new crew members in particular who are just new to the environment. But really my biggest role on board is to organize events for the crew and to get them involved in making decisions about how their facilities are best used. Things like the crew club, the officers and staff club, the aft deck where we have 2 jacuzzis, our gymnasium for aerobics and our gymnasium for weights, our international reading gallery, and something that's kind of new for us, the internet cafe with 7 stations.
The feverish pace of the work has paid off. As the crossing nears completion, so has much of the work. Areas that only 2 weeks ago were unrecognizable now reveal their true form. But there is still work to be completed. One of the last tasks will be finishing the installation of the art. The art had to wait for many of the areas to be completed before installers could get to work. And there was plenty of it to install, more than 4,000 pieces valued at $12 million. The centerpiece of the collection is called The Dancer.
This is the main signature piece for the ship, and it's designed and constructed by Larry Kirkland. Effectively, it's a huge disc in the ceiling of the atrium from which the cables are suspended, the elements are attached to those, and it's all collected into this large basket arrangement here down on deck 3. The large disc at the top is heavy section aluminium, which is pierced, and then the steel cables are suspended from that.
The variety of the art covers a wide spectrum of styles. Classical and contemporary sculpture, oil paintings, frescoes, even mosaic. This very complex atrium piece, designed by the ship's architect, took the full 2 weeks of the crossing to install. The extensive art collection is worthy of any museum. After nearly 2 weeks at sea, Voyager approaches her home port, Miami. The placid waters of the Channel are a welcome change from the rough seas of the Atlantic crossing. She is greeted by the media, spectator boats, helicopters, and the curious. Voyager of the Seas is home. She must now be ready to meet the public. There are tons of debris which must be removed, and every inch of the ship will have to undergo an extensive deep cleaning. It's a tradition for a ship to have a godmother. Voyager is the first at sea with an ice rink, so it's only natural that two-time Olympic gold medalist Katarina Witt serve as her godmother. As part of the festivities celebrating the maiden voyage, she will star in a network televised ice show taped on board Voyager, featuring many of the world's best-known skaters. It's also the godmother's responsibility to preside over the official naming of the ship.
On behalf of our board of directors and our 20,000 employees, it is my pleasure to extend a warm Royal Caribbean welcome to each of you. I am very pleased that you could share today in a celebration of one of the proudest moments in the history of our company.
I'm very happy to be here tonight with all of you and name this beautiful ship. I'm especially very, very honored to be the godmother of the biggest cruise ship in the world. I named this ship Voyager of the Seas and bless all of you who sails on it.
I'm an athlete.
It's been more than 3 years and 10 million working hours, all in anticipation of this moment. Voyager has welcomed her first paying passengers and now sets sail on her maiden voyage to the Caribbean. Any doubts that Voyager would not be ready for her debut have been laid to rest. The vision has become a reality. She is the grandest ship afloat, a marvel of human ingenuity and achievement, more than fulfilling her promise of a vacation like no other on Earth. We have seen the evidence of creation. We have seen a grand idea manifest into a great ship of grace, grandeur, and beauty. The Voyager of the Seas is not only a triumph of global cooperation and visionary design, it is a lasting tribute to the ingenuity and genius of humankind. I'm Roland Smith.